serious. And well, serious, we will try and write a web service in Golang,
Golang, right? Okay. So I've
right?
never done Go before.
Yeah. So, well, even if I talk just about myself, so I think I picked up Go around 4 or 5 months ago only. So it's pretty simple to pick, right?
Mm-hmm.
And as we'll see, writing a web server on it is
Mm-hmm.
damn simple.
Okay.
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 Uh, cool. So I'll just maybe uh, briefly tell about what I plan to do, and then maybe, whenever you have any questions, right, just pause
Mm-hmm.
me and we'll go into depth there.
Okay.
Okay. So the idea is basically to come up with a very simple web service, right? Just to illustrate how simple it is to create a web service in Go, and maybe talk a bit about how Go is a bit different from other languages syntactically, right? Or where things are, better or feel easier than say compared to other languages, right?
Mm-hmm.
That's one thing.
Mm-hmm.
And then we'll also try and keep adding some more logic to the web service and maybe, make it sound decently useful. So the plan here is that I will create the web service in such a way where, say, if I expose it on the internet, right?
Mm-hmm.
Someone should be able to ping the web service, and you may remember that. I don't know if we still do it or not, but long ago on the internet, when I was a kid, whenever I used to go to the internet, I will go to a page, and the page will be like, your IP is xxx.xxx, right?
Yeah.
So that's what we are going to implement, right? I'm
Okay.
just going to shock my client and tell them what their IP is.
Okay.
Okay, so that's all that we are going to try and do with the web service,
Okay.
right? So that's the plan, and let's see if we have time. We'll try to do more stuff. Cool. Okay. So creating something in Go is very easy. I will just create a file called main.go.
Mm-hmm.
And as it is obvious, the terminology is coming again from the C family of languages, where you have an entry function which you usually declare as main, right? So Go
Okay.
also has something like that.
Mm-hmm.
So Go has a concept of packages. Okay, so basically a bunch of functionality is packaged together under a package, right?
Okay.
And the entry package, if I can say, is basically your main package. So whenever you're creating an executable, there should be at least one source file which has the main package, which should have the main function, right?
So yeah, main is just like main in C, I guess.
Yeah. So yeah, thanks for highlighting that. So one of the cool things about Go is that my view of Go is that Go is basically a mix of C and Python. That's how I like to look at it,
C and
because
Python. Okay.
yeah, because Go was designed at Google, right,
Mm-hmm.
for its own purposes,
Mm-hmm.
and majority of the engineering at Google primarily uses C, C++, or Java. Well, let me say they used to use that
Okay.
when Go was being designed.
Mm-hmm.
So Go is designed in a way that it is very comfortable for people familiar with those languages to transition to Go. So
Ah,
the learning curve isn't very steep for them.
right.
Supposed to be very small for them, right?
Okay.
Okay. Okay, let me actually not do anything here.
One thing
And
though, why do we say
yeah,
package main? What's a main package? I mean, func
what's
main, I get that it's like the main function entry point of the program.
mhm.
What's the line package main? I mean, it reminds me of import from Python and hash include in C.
uh yes, okay, cool. Oh, okay, let me just do one thing. Let me just try and build this and let me then
Okay.
come back to
Sure,
this.
sure. I
Okay,
mean, go run with your flow. I'll just keep
right,
interrupting you whenever I find something
sure. So as you
interesting.
see, right, we just built a binary
Hmm.
called main, right? Because okay, so the general convention is whatever is the name of the binary,
Hmm.
right? Oh,
Hmm.
sorry, the name of the source file. If it
Hmm.
is main got go, so it will create a binary called main, right?
Okay.
And let me just oh, let me just see the size of this, right? It's 1.1 MB,
Okay.
right?
More
I mean,
than
if you think about something which is just doing nothing, right? You should not be a static binary. You do not really have concept of something like object files that you used to have in say something like C, right? Where you will have intermediate files and then you are linking all those intermediate files and then creating a final binary, right? So you
Mm-hmm.
don't see all those intermediate steps happening here. They do happen probably somewhere in the background, right? But you are not exposed to it. What you end up getting is just a final binary, right? There's just one single binary that for say every binary that you're trying to create, it will create. And it has a lot of stuff in it. So basically, Go does not allow you, or Go basically takes care of garbage collection for you, right?
Oh,
So
okay.
unlike C, you do not have to go every place and be like free, 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 right? You don't need to do that. Go will take care of that for you, just like Java, right? So
Okay.
that basically simplifies things to an extent for people, right?
Mm-hmm.
And because it is a garbage collected language, so I am assuming all that logic goes there in the binary itself because it does not require a virtual machine like Java. So I'm just going to run it like this,
Mm-hmm.
and that's it, right? I've just executed the binary,
So it quit?
right? And there's no logic there
Yeah,
right now, so it's not
correct.
doing anything. So let me just go here and maybe add something useful. So, uh, right. So let's just do this, and I'll just explain what is happening there. But right. So, oh, oh my bad. And actually, there's one more command which I can just directly use. Just run it directly, right? So instead of go build, I can just say go run and just execute. It'll just build the binary and execute it.
Ah, okay.
But it will, and if I just remove this, it will run it, but the compiled binary will not show up here. Okay.
Mm-hmm.
Okay. So as you can see, right? Uh, okay. To build it and then check the size. Okay. 1.9 MB.
What just happened? Format dot print and it
Yeah.
doubled in size.
Yeah. But because if you look at the source now, right? So now
Mm-hmm.
what we're doing is we're importing another package called format,
Okay.
right? The format package is basically
Okay,
doing
so there is
all,
a import. Package
yes,
is not import. Import
package
is
is not an
import.
import, right? So
Mm-hmm.
packages say something like in Java at the very start, right? You
Mm-hmm.
define the package,
Mm-hmm.
right? And so that is, I think that's how you can compare this main two, or I can create any other package, right? So I'm just basically collecting together a bunch of source files or bunch of functionality in one package, right?
Okay.
Similar to what you do in Java. In the sense of Java, we are explicitly declaring it at the top of the file,
Okay.
right? And then you've got the import line where what you're essentially doing is you're importing a package,
Mm-hmm.
right? Uh, the usual convention of importing a package is that whenever I'm trying to import a package, I am going to give it the full path, the fully qualified name for
Mm-hmm.
that package,
Okay.
right? So again, in that sense, it's very similar to uh, Java. So if I had a package, say, okay, so one of the popular examples that is there is, say, I have the domain example.com,
Mm-hmm.
right?
Okay.
And if I was just say trying to use a package from there, so what I'll have it would be example.com slash say the package name is hello, right? So this is how I'll be importing the package, just very similar to what we do in Java, right?
All
And if
right.
I wanted to go ahead and use it, I would just say hello dot and whatever is. say it had a functionality called hello,
Hmm.
and that would be it, right? So that's how we use packages. If it does not have a, say, a name like this, right? What it usually means is that this is a package in the standard library,
Ah.
right? So I can have another package, say, called hello, right?
Mm-hmm.
But under a different fully qualified name, right? And if I
So,
wanted to
so
use
when you
this
give
also
this
here,
domain name, what does it do? Is it like it fetches things over HTTP?
so what it will do is basically Go now has uh, a standard server. So they've created a proxy server for all packages. Actually,
Ah, I see. Okay. So there
right.
is
So
a
they've created
server
a
running on your local host.
no. So
No?
there is a
Hmm.
publicly accessible server
Oh,
where
okay.
all these packages are available, right?
Okay. Okay.
And all these packages can be accessed by them. Or if say you're running, so if you are say a company, right, software
Hmm. Hmm.
company
Hmm.
who have their own internal software that they do not want to expose to the world,
Hmm.
so you can run your own proxy server,
Hmm.
right, in your own well closed
Hmm.
network,
Hmm.
and you can configure basically the applications that will be compiling this code, right,
Hmm. 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 Hmm.
to fetch from those servers basically. So
Well,
this
like a
just
default
yeah, so the
namespace.
default is the globally accessible public server,
Hmm.
and if you do not want to use that, if you want to add some private repositories also, right, so you can provide the well the path to those
Okay.
private repositories in a configuration manner,
Hmm.
and sure we can fetch from there basically, right?
So even though the binary, so here's the thing. So if let's say we have a binary like this 1.1 MB file, right?
Mm-hmm.
Uh, there is a possibility that certain binaries of Go
Mm-hmm.
might not be able to function without the network or
Without the network,
at
yeah, okay.
runtime or
No,
or
no. So
all
because it
this
is a
gets
static
resolved at
binary,
compile time.
it's only at compile time. As I said
Okay,
earlier, it's a static binary. It
okay.
has no external dependencies.
So at least while compilation, it needs to hit the network once if it is accessing something over the network.
Even hitting the network may not be required
No, no,
if
I
those
mean, yeah,
packages
even if
are
it is
already
some
available
everything is
locally.
locally, then it will have to hit that locally once. And
Huh.
then that 1 MB file or 2 MB file you copy to any PC in the world, it'll work
Hmm.
without
Yeah.
network or without anything else.
Yes. Yeah. Basically, that's the standard way, right? So
Okay.
whenever, I mean, if you are familiar with Java, what I remember is basically if you
Hmm.
use, say, something like Maven, what Maven will do is
Mm-hmm.
it will hit the internet, right? Retrieve the relevant packages and
Mm-hmm.
then store them locally, right? So next time it does not have to just go through the
Right.
entire process, right?
Right.
So that's the standard way of doing it.
Okay.
Okay. Anyway, and just wanted to highlight something. So if say uh, so if you have two packages
Yeah, some
with the
of
same
those
name,
paths it's not able to
yeah. So right
resolve.
now it's not able to resolve because there is no. I don't think there are these
Example.com.
are valid ones, right?
Correct.
Right. If you want to just rename, so instead of using hello, if you want to just say what H, let's just call it H,
Okay.
right? So you could just do like this, and this would work. So basically, otherwise you would be using hello, whichever is the this is the last one is the package name, right? And in cases where there is a clash in the namespace, right?
Hmm.
Because there are two packages with the same
Hmm.
name, what you're expected to do is usually,
Give a
rename one of the
short name.
packages,
Yeah. Okay.
right? Just give anything which makes sense,
All right.
right? So that should help you with the packages part. Okay, so that's that. Okay. Uh,
Hmm.
Now if I think about, okay, so I just wanted to talk about format. Yeah, so the format package is basically related to so basically reading and writing, actually writing strings basically or formatting strings based
Okay.
on the format string that you have.
Right.
similar to what you have in C and C++ or say any
Mm-hmm.
other generic language, right?
Mm-hmm.
So that's what we are trying to do
Okay.
with this package. Okay. So if I now want to say create a web server, what I
Right.
would do is something very simple. So one of the things that you need to know about Go is that Go was created at Google, right?
Mm-hmm.
Some time back around in 2007 or 8 is when they started working on it. I think
Okay.
the first public version was released back in 2009. And one of the design goals that I think that they used is basically they were writing Google at the point of time was big into creating web services, right?
Mm. I guess they
Uh,
still are.
they still are, but at this point of time, they were very much into it, right?
Okay.
And probably one of the things that they were trying to solve is okay, the future is going to consist of distributed systems, right?
Mm-hmm.
Where you have a lot of servers being where a lot of servers are being run,
Mm-hmm.
and you want to have a language where it is probably easy to create servers, right?
Mm-hmm.
And with probably that as sort of a design goal for the not the language but the standard library, what they ended up doing is basically creating a few packages with which bringing up a web server in Go is super easy.
Mm.
Okay, so they have this package called HTTP, and this is handle func, right? And let me call it default handler. Okay. Listen. Okay, so what I'm doing may seem a bit weird, but I'll just explain it in a minute. Um, okay, so here it is going to crypt because I have not defined a function. So I'm just going to define this default handler. Hmm, Right. Hmm, Cool. Uh, okay, so and now I have this here up
Right.
and
So it
running.
didn't quit. It just
Yeah,
kept running.
right. And if I hit
Hey,
localhost,
nice.
right, I've got the
Right.
server up and running. And you can see that this is bare minimal code that you have to write for
Cool.
getting a web server up and running,
Yeah.
right? And I'm just making use of all standard library stuff,
Mm-hmm.
nothing fancy, no framework,
Right.
just so it's very easy to basically create a web server
Hmm.
in Go.
Yep.
Okay, so let's talk a bit about what is happening here. Okay,
Mm-hmm.
so what we have here is the HTTP package, right? Part of innet/HTTP. What is happening here is basically it will create the web server for us, right?
Mm.
When I'm doing listen and serve, right, I'm just telling it, okay, you need to listen on port 8080 of this machine for any incoming HTTP requests.
Right. What's
Cool,
the nil though?
right? The nil is basically so this can take so I can create my own HTTP handler
Mm-hmm.
and pass it, right, and it will use it. So I'm not really using it as of now. So yeah,
I
just
mean,
leave that
but
as
we
in.
already passed a handler in the. Handler func.
Yeah, I mean that's a bit different. I'll just come to that.
Okay.
Right. So if you look at this handle func, so what it is doing is it is so the way I have seen HTTP servers being written is
Mm.
what you'll have is at the very top level you'll have a router, right?
Yeah, the
So what
root
is going to
node
happen
or
is
something. Mm.
so basically what you'll have is your application is listening on a port
Port.
on that machine,
Mm-hmm.
right?
Mm-hmm.
It basically will perform a bind on that port, keep listening for any incoming HTTP request on that port.
Mm-hmm.
Once it gets an incoming request, right,
Mm.
it is going to look at the URL or the URI,
You are right, right, correct.
right? And it is going to, and so basically the first part of that is going to be your host name, right?
Mm.
Say I am running this at example.com,
Mm.
right?
Mm.
Right. So, so basically, if I okay, I'll show this. Yeah. So basically, if this is my request,
Mm.
example.com slash, right? If this is my normal request,
Mm.
right?
Mm.
Then this is the path basically. Then this is the root path basically,
Correct,
right? So
correct.
this is what it is matching to.
Mm.
Okay. And if that is the case, and if basically whatever is the request, right, after removing the host name,
Mm.
basically, which is okay, my bad, which is this, right?
Mm.
All I'm left with is the slash, right?
Mm.
So this is the root. And this and if any request matches to this,
Mm.
then what I am supposed to do with that request is I'm
Call
supposed to
this
route that
default
request
handler.
to
Mm.
default handler,
So we
right?
can have multiple handle functions for different paths.
Exactly.
Okay. How about we add one more and curl the
Sure,
default path?
sure. We'll do that. Just let me explain what default handler is doing, and
Okay,
we'll
okay,
go to that.
okay.
Okay. So what we are doing in default handler is first of all expected to support a certain function signature,
Mm-hmm.
right? Which is the expectation for handle func, right? So it is going to take in a handler function.
Mm.
So right, if you see there are two input parameters. One is
Mm.
the pattern parameter, which is going to be a string, and the second is going to be a handler parameter,
Mm.
which is going to take in
Function pointer.
response from HTTP response writer and
Okay.
a HTTP request, right? So that is the
What do
uh,
you call this though? Like a handle to a function here? Or do you call it pointers like in C?
we don't really. So I think
Is there a concept of
okay.
pointers here?
So basically, functions are first class citizens in Go, from what I
Okay,
recall,
okay.
right? So
So
you
it's
can
like a
just use
function
them.
object. It accepts a function object. Func.
E- I would not want to call it an object because it's technically a first class citizen, right? So
Mm-hmm.
you can, so wherever you can use a variable, you can just throw in a
So
function
func
there,
is a type. Okay,
right? Yeah, I think
okay.
maybe yes, that's how you can look at it.
Mm.
Okay. And what we are doing here is very simple. We're not doing too much here. What we are doing is we are anyway ignoring whatever the request is. We are not using any information from it as of now. What
Right.
we are doing is we are making use of the response writer. And in the response writer, what we are doing is we are taking the response writer and we are writing this message to it,
Ah, okay.
right? And this then basically is the response that we are getting. So if I curl with verbose request, this probably is right. So what you can see is it's a get request to slash
Mm-hmm.
HTTP 1.1 and you are getting being returned a 200, right?
Mm.
And this is the response that you're getting,
Okay,
right?
nice.
Cool. So as you had requested, let me come up with one more line and I'll show you something interesting here. So let's call it ping,
Okay,
right?
okay,
Uh, let me call it ping handler.
okay.
And this should be, this is what the URI should be, right? I'm just going to copy this
Mm-hmm.
and I'm just going to do this. And what I'm going to do is just going to add Pong here, right?
Okay.
Nothing too complicated. Uh, so again, we'll go build
Go run.
main,
Okay.
right? And what I'm going to do now is do a thing, right? And if you
And
see,
we get a punk.
you
Okay.
get a pong,
Mm.
right?
Mm.
Again, same sort of stuff, right?
And if you hit slash, it will still return the previously in server, right?
Yeah. So
That
actually,
continues to work.
let me just not go verbose. Let me just show you this, right? Now let me show you one more thing. Let me say I misspell it,
Hmm.
right? So getting the default one,
Oh, okay. So how
right?
did we register that? Can we see the
Huh.
code?
So the logic in this handle func is basically that what you basically have is in the router you are passing a string,
Mm-hmm.
right, and
Mm-hmm.
a handler function,
Okay.
right? So and whatever is the URI after removing this uh, host part,
Mm-hmm.
you are left with a string, right?
Okay.
Now the router is going to do a pattern matching, right?
Mm.
And what it will do is there can be say multiple entries which can match to the same entity. So let me actually just say, let me just create say something, right? Let me create this and let me call this ping a handler. Weird naming, not
Mm.
a great naming convention, but let this just to show an example of what is work. I just modified the response, okay? And what we are going to do now is again going to go up
Go run.
and go build, right? And right, so right, and we have this.
Mm.
And if I go to A, take a pong, but if
Mm.
I do B,
Mm. I see. It skipped slash ping though, right? It went all the way to
yeah,
slash.
I think okay. Let me just modify this and let's see.
Mm.
Maybe
Mm-hmm.
maybe that is the expectation there. So basically, all it does, from what I understand, is it will try to do a pattern match, right, on all the strings that are there.
Mm-hmm.
Uh, yeah, that's it.
Ah, nice. So with the trailing slash, we're telling it it's like a star. Everything in this.
Everything after it
Mm.
should match, right?
Mm.
So what it is doing is everything should match, right? On line number 9, everything should match.
Mm.
Line 10, what we are saying is everything which leads with a slash ping
Mm.
and anything after it should match. And then the third one that you've got is everything that leads with a slash ping slash a,
Mm.
right? But if there is any extra stuff after it, it will not match, right?
All right.
So if I just do
Ping G. Like without
a
okay,
a
it
works, but
matches.
if I do an ab, right,
It
it
goes to
takes
slash ping.
yeah.
Yeah.
So what it is doing is basically it is doing a match, and whichever is a match, so it will have a bunch of it can have a bunch of matches, right? In this way. So if I
Mm.
have like a default handler,
Mm-hmm.
the default handler is always going to match every request, right?
All right.
So you can have multiple matches. So the way it does a break against, or the way it basically decides which of the matches it is going to use is whichever is the match with the longest length, right?
Okay.
Basically, whichever is the one with the maximum depth,
Mm.
in a way,
Mm.
is the one it is going to allow,
All right.
right?
So when it matches something, we still have the complete URI though, right?
We should have the complete URI, yes, right? Uh, Let me
So ping handler or default handler, for example, can try and figure out.
just try and do something. Let me just use the logger. And this should be dot URL. Let me see if this works. Where did I
You
add
need
it?
to hit ping slash a.
Ping a handler, okay. Uh,
Where is
yeah.
it logged?
Oh,
Okay.
but it has only, so it is calling this the URL. This is the path that we get.
Right. So the host name was removed, which kind of makes sense, I guess. That will vary depending upon where it is hosted. So it would know. Okay.
Uh, and URL dot URL. Wait, let me just uh right. Yeah. Oh, there's an extra. Okay, sure. There's an extra slash there,
Ah, that's
but I
fine.
can
That's
remove
fine.
that, right?
Yeah, that's okay.
Right. So that is that. So that's the way you can basically get the entire URL of
Hmm.
the request.
Nice.
Cool. So that is one way. And okay, so there are a few things that I'm not sure if you have noticed are different from what is normally there.
Hmm.
So just look at the function definition, right?
Hmm.
So say let's look at the default handler. So the way it is
Hmm.
done is you have this keyword called func to tell
Right.
you that this is going to be a function, right?
Hmm.
The name of the function.
Hmm.
And then what you have is basically the variable
Hmm.
and the type,
Type.
right?
Right.
Which is very different from what you normally have in C, Java,
Hmm.
right? So in C, you will have, say, you would have response writer RW, right? But
Right.
here
The
we've got
type
RW.
type and the names have been swapped.
Yes,
Okay.
they've been swapped, right?
Hmm.
And this is one of the interesting things about Go, basically, right? And the reason is basically by having all the type on the right,
Hmm.
you can read from left to right, and it becomes very clear what the variable is referring to, what the type of the variable is basically,
Hmm. Okay.
right?
Hmm. What's that
That's
star though? There is a star HTTP dot
yeah. So
request.
star HTTP means it is a pointer to an HTTP dot request.
Okay. So it's called a pointer?
Yeah, it is a pointer.
Okay. Nice.
Okay. I mean, Go does have pointers.
Okay.
It's not like it does not have pointers.
Hmm.
But it does not allow anything, any of the usual sort of pointer arithmetic
No
that you're
pointer
allowed in application.
manipulation.
No.
Okay.
From what I understand, there is no pointer manipulation. Well, when I say that, it's not entirely correct because I know there is a package called unsafe where you are
Okay.
allowed to do a lot of things with
Nice.
pointers,
Okay.
but it is
It's
explicitly
frowned
called
upon,
unsafe.
kind of. Okay.
Yeah.
Okay.
So
One other thing though, so when we get our star HTTP request, what happens if we try to modify HTTP request now?
if you try to modify
R.
HTTP request now, R, sure, the object should be modified.
But I mean, logically, it doesn't make sense to allow someone to modify a request. It's not like the client which is hitting this server will get to know. So does Go catch
Uh,
that, or does it allow it to happen silently? There are no side effects. There are side effects. What happens?
so, okay. Since we're talking about it, what this basically means is if I'm going to modify it, there are going to be side effects, of
Oh,
course,
okay,
right?
okay.
But the thing is, again, copy by value and copy by reference
Hmm,
is what is
hmm,
coming into action here, right?
hmm.
An HTTP request can, I am assuming, can be pretty big. I'm assuming if you just go through it, you're going to have a lot of stuff.
Right.
So probably it just made sense for them to just use a pointer and you
So
have
what
a copy.
happens if we modify it here?
What happens?
Can we
I think the
see?
struct should be modified, but I have not seen any example where it is modified.
Right, logically it makes zero sense that we modify a request on the server side.
Yeah,
Makes no sense. Yeah,
and it makes no sense. Yeah,
yeah.
it makes no
Logically it
sense.
doesn't make sense, but practically does it happen? Does it allow you? Does it
Yeah,
work?
I mean, if I probably want to modify something, it should allow
It
me to
should, right?
modify.
Okay.
Right?
Shall
Let
we
me
try?
try.
Yeah.
Let me try. URL should be. What is it going to play? Field of.
Yeah, something like this, and then try to print.
Wait. Let me go for host. I think host is a string, right?
No, hold on. Could you retain that print anyway, which we were printing the host and the name, and try to modify it before? So we are
Mm-hmm.
logging something, right? Let's keep that as is and try and modify R before we attempt to log. So does that reflect or not? We'll be able to see.
This is what we had, right? And I've just modified the host instead of local host.
Yep.
So this is local host here, right? So it should no
Yes.
longer be local
Does
host.
it say my host? Does it fail to compile? It
It should say
compiles.
my
Okay.
host. Let's see. Right? It does.
Yes. Okay.
Which is as expected, right?
Expected. Yep.
Cool. So you can do this. And okay, what else do we want to do? Mm,
You know what? The more I look at this handle func, it kind
mhm.
of reminds me of how we register function handlers in a Flask based server. So Python has this package
Yes,
called Flask, right?
yes. So that is, so if you look at it, right, so that is more or less the way it works in my experience across frameworks
Okay.
for building web services.
Mm-hmm.
So I have worked uh, on Flask also a bit, right?
Mm,
So Go has frameworks, right? I mean, this is a very simple one. This is the default router that you have.
mm,
Go has frameworks like Gin and Gorilla,
okay.
uh, where you can do much more advanced stuff. But yeah, sure. The basic routing of the requests is done in this only, where you're
Mm,
just doing a URL matching,
right.
URL as defined by this, right?
Mm,
You're doing a URL matching, and basis of whichever is the longest URL which matches, you just forward it to the relevant function handler. And
correct.
I think you can this you can probably spin it up in a separate thread, right, and let it process the request, and
Right.
it will have like the response writer coming back as a response, and then you can just
Correct.
format it to whatever is the HTTP data format and just throw it on the wire,
Okay. Yep.
right?
Yeah.
So that's how. So once you are familiar with at least one web framework, switching between them is not going to be that much pain.
Mm, right.
Okay, cool. And what can we do? Okay, so we wanted to figure out the IP, right? So,
Yes. We want to upsell them into buying our fancy VPN.
of course.
I mean, why stop at IP? Let's see what else we can figure out and print all that. But yeah,
Right.
let's start with IP.
Okay. Just want to highlight the naming convention. So there is this slight difference in naming convention in Go,
Mm-hmm.
where say if you were working in a language like say, Java, so IP is an acronym, right?
Mm,
And it's written in all caps here.
right.
Compared to what you'll probably do in Java is where you'll just capitalize I, small
Mm-hmm.
case p,
Mm,
right? But this is the expectation of the convention.
Okay.
in
Is
Go.
there some sort of linter or something um, which complains or
It will
flags?
probably not, because this is something which is
As in,
context specific,
does
right?
the Go toolchain have something like that, or are you aware of any such?
Oh, sure. Go has okay. Let me just do one simple thing. This is okay. It is probably just going to complain right now. So let me not do this. I will do this. Okay, let me not do this here. Let me copy this here. Let me do get IP handler, right? Uh,
Right. You're a spy.
right. Let me just, for the sake of showing, do something, right?
Yes,
Okay, so right now you'll see that this is not aligned, right? In the
correct. No
code is not
indentation.
aligned,
Yep.
right? And now I'm just going to save it. You can see colon
Right.
W,
Sure.
right? You see it gets auto aligned,
Hey, interesting.
right? So what you have basically is there's a tool called Go format, or basically the way
Hmm.
it works is Go FMT, and you give
Mm-hmm.
the name of the file. So say I create a copy of main.go. Okay, abc.go. Let me just open it here. Not a crib. Okay, let it crib, right?
Mm-hmm.
And let me do this, right?
Mm.
Now I do a go FMT, right? And
Line 18, has it fixed the missing tab? Yes.
yes, right? You can see this.
Yep.
So Go is a no-nonsense language when it comes to formatting code.
Mm.
Okay,
Nice.
so he just says that, hey, there is this one way of formatting your code,
Yeah.
and
One
no
less thing to
arguments
worry
about it.
about while reviewing.
Yeah, I mean, it does not give you any say into how code should be formatted.
Good.
It's just that, okay, hey, this is how we are going to format a code,
Nice.
right? Part of the toolchain itself.
Good.
One of the good benefits because of it is it standardizes
Yep.
how your code is there, right?
Yeah.
And what it allows you to do is basically, if you want to do a rewrite for, say, some specific sample of code
Mm-hmm.
in the entire code base,
Mm-hmm.
it goes powerful enough that you can use just the toolchain to perform a rewrite in the entire code base for a specific, uh, say, text of code. It will search all existing matches for that section of
Mm-hmm.
code,
Mm-hmm.
and it will replace with whatever you're asking it to replace with.
Oh, nice.
That is made possible because there is only one possible way for formatting,
Ah,
right?
nice.
With the fact that the abstract syntax tree parsing is also made very easy. And Go has a lot of design decisions that went into place to optimize just taking a source file and creating a AST out of it.
Mm-hmm.
So there are a lot of decisions that were taken to ensure that that was very fast. Because one of the complaints that actually led to the formation of Go was, hey, compiling this code takes a lot of time,
Mm.
right? So Go is super fast to compile, super fast to test. Super. So it is basically built along the philosophy that you should be able to just write the code, compile it, and just be able to deploy it as fast as possible. Well, the deploy part
Yes.
is my own opinion, but basically, yeah, it's supposed to be very fast. The tools are not supposed to take too much time,
Mm.
right? And by decreasing that time, you allow the programmer to iterate as much as possible, right?
Right, right,
Which
absolutely.
is our experience with any, say, scripting language, right? It
Mm.
is very easy to make change and just run it once again,
Yep,
right?
yep.
It does not take 20 minutes to compile, and then you figure out, oh, I forgot this corner case, right?
Yep.
I mean, that's also good in a sense where it forces us to think through what we are writing without allowing us to just write dumb code.
Yeah.
But sure, it's not always useful.
Mm.
Okay. Uh,
So coming back,
so
we were playing around with this get IP handler,
yeah,
and
so okay,
hmm,
right? So what we can do is very simple. You'll have r dot
so assignment is colon equal to okay
yes.
r dot remote addrs. Hmm, 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 hmm.
Uh,
So is that a
it,
string?
it should be it is a string. So if you see, so this is the convention basically. It's a
Hmm,
variable
hmm,
of I called IP of type string, right?
hmm,
And like a lot of languages, it can do automatic type inferencing,
hmm.
right? So no need to explicitly tell it, hey, this is your type.
What's the type
And
of remote addr?
yeah, that's
String?
also string, right? It's string.
Okay.
It is string, so that is why it is able to infer
Hmm.
in this string.
So is string a standard data type in Go?
Go, yeah,
Okay.
and yeah, IP, all right. Uh,
Okay.
uh,
What do we do? IP? Nope.
oh, my bad,
Slash IP. Yeah.
right? So since both of so basically I'm making a local request. So yeah, but you can notice that the port number is different every time,
Uh-huh.
right? Which is what you probably expect.
This is new to me though. I mean, yeah, because it's running locally, it's not going to give you your public IP. That kind of makes sense. Hmm.
Right. And anyway, it's actually giving me the combination of both the IP and the port.
This is
I'm not
something
sure.
interesting. Yeah, so I was expecting 8080, but then it looks like each time we do curl on
Mhm.
localhost 8080, the remote address is different.
Yeah, because this is the 8080s
Server side,
where the server is listening, right?
and curl is like a client which runs and binds to some port, available port. In this case, that available port number keeps increasing.
Right. So if you look at this is where we are trying to make the request to,
Right.
right? And okay, so this is again information about the same.
So it's like curl spun up an instance on 57840,
Yes,
and that I don't know the exact term, maybe not bind or whatever, but then that hit the server on 8080.
yes.
Hmm, interesting.
Mm, cool. So I had plans of exposing this to the internet also. There is a very simple way of doing it, but I
There is
thought that will just be
some, yeah, there is some, I forgot the name of that service which allows us to, I
which
think
allows you
it's,
to basically forward your local port to the internet,
yes, yes,
right? And
yes,
you have a unique URL which you can use to access
correct.
it.
What was that guy? I remember doing that when I was trying to play around with some Slack notifications. So Slack needed a webhook
Mhm.
which was accessible on a public IP, so I had to get Nmap. No, no, not that's a tool. Ngrok,
Yeah, I think it is ngrok. Right.
Ngrok.
I think it is ngrok. Yes,
Yeah,
it is ngrok.
Ngrok, right? Okay.
Yeah.
Shall we
Basically
try?
create basically creates a tunnel. Let me see. We can give it a shot. Not too much pain. Grok 8080 forwarding to okay.
Okay.
That is what
So
it
we can
is.
curl this, right? We picked up HTTPS. Didn't make any difference. Okay, it still works. We don't get our public IP though. Why?
Uh, 57846, is that it? Oh, wait, you will not get it, right? So if you see in all three requests, it is giving me the same one
Hmm.
because there's a local tunnel to which it is talking. It is not getting those requests from the internet.
Come again?
So basically, it is so there is a tunnel which ngroks create from my machine to a public machine, right?
Correct.
So ngrok is basically
Ah, I see
so
what you mean. So,
right.
the
So
server
ngrok
just
is
sees ngrok.
the server is seeing requests coming
Ngroks.
from ngrok because it is a tunnel. It is not exposed
Hmm.
on the internet directly,
Hmm.
right?
How
And
do we
that is why it
find
is.
something uh, which is the true source? Maybe not remote
Well,
ADDR.
yeah, I mean, this is the reason why I did not want to do it today because it will take some amount of time. I mean, an easy way of doing it is just containerizing this,
Hmm.
pushing it on something like AWS and running it and seeing the logs.
Right.
That's
No,
not
no,
very
I'm just
difficult.
thinking of it from the other angle, saying as a server, we get to run as many packages as we want.
Hmm.
Is there some way of finding the true origin? That's something that hit
The
me
true
now.
origin actually, no, so it depends on who is forwarding you the request, right? If the
Hmm.
intermediary decides to strip out information, there's
Hmm.
not much you can do,
True.
right?
Yep.
Cool.
So how do these websites, shady sites with such ads, how do they work? At least they seem to be able to get my public IP,
But your public IP
or
is
ISP probably
probably
exposes
is
that
the
anyway. Yeah.
yeah. So the public IP is the IP of your ISP, right?
Hmm.
It's not your internal IP. You don't
Correct,
really
correct.
have a public IP.
No, no. What I meant to say is I get an IP at my router.
Yep.
So when I am making a request, they
Mm-hmm.
are seeing the public IP of the router, of
Mm-hmm.
my router, which
Mm-hmm.
I used to connect to the ISP. They don't see the IP that I have in my internal subnet. That's true.
Actually, this is a good thing. Let me try doing this.
Hmm.
I'm just making an experiment. Let me.
Okay. So now it's become 215 57858. Okay.
Oh, that is the port basically, anyways,
Hmm.
right? That
It
will keep
keeps
increasing.
change.
But basically, now I'm routing it through my wireless router, right?
Correct.
So now because it is coming from the wireless router,
Hmm. What
right?
if you
Because
set
it
up
is,
ngrok on, does ngrok allow such a way to set up?
I don't think, and I am not sure,
Okay.
but the default way does should not, because it is
Yes.
because we want a secure way of exposing it, so it will
Hmm.
probably not allow anything to just go over the internet, right?
True, true.
That's why they create a tunnel. Cool.
Nice.
Anyway, that's that. Uh, just one more thing that I just wanted to show is, uh, so we are using the log package here without really doing anything about it. Uh, Let me just create a logger
Hmm.
log.new was which I am again going to dump to std out and just got to call it IP finder, which is just going to be a prefix for every log line.
Hmm.
And I'm just going to just set the standard flags. Right. Because instead of something like this, I'll just give it to declare. Why is it cripping? Oh, yeah, because I can use it only there. Oh, So I'll just create it here,
Hmm.
and I'll have to just look at pointer log, not logger, right? Okay, so this is also something I don't know. So if I take, so if the declaration and uh, pass you setting the value or separate,
Hmm.
then we do not use the colon, just assigning the value here. It's so
Colon equal
simple.
to is dual operation. Got it.
Yes. So we're creating a variable as well as assigning it
Hmm.
something. But if I just want to separate them, this is the way,
Okay. Uh,
right?
and let's add that logger back.
Logger dot. I don't know what I was writing here.
Hmm.
Logger. Um,
Bingo.
can
Right.
probably. Uh, uh, just some of stuff like this. We'll just add this here.
Mm-hmm.
Or this here. Right. Um, right. And if we go there, you can see the logs basically, right?
Yes.
Right. So IP handler was invoked, and it will say get request. I can then probably just go for ATT and say ping. Whoops. Okay. Not sure what I did wrong there.
uh, uh, there seems to be a redirect if we do slash ping
Oh, okay.
with a trailing slash. We are able to see that.
Okay. Cool. Wasn't aware of this. Ping it, expong. Right. Cool. Okay. So that is
That's
regarding
the server
logger.
in Golang.
Right. And this is all using the default stuff. I mean, you can create your own router also.
Ah, so we can add our own sort of pattern matching logic.
If I remember correctly, this should be new cert marks. Right. And this is what you pass here. And this should work as it was working earlier. Right. So you had a question earlier, right? Why was this nil?
Hmm.
This was because it was taking the default cert marks, which is there as part of the standard library itself,
Ah.
right? Uh, but if you have say if you want to use a different serve mux, right? You can do that also, right? And okay, let me show you one more thing. So right now I have hard coded all this information, right? Let me actually create a server also. Actually, can't seem to recollect which is the wait, lessons. Okay, this. Okay, I don't remember which
So
is the one.
what's it that you're trying right now? So in line number 22, you're saying server equal to.
I want to create a server.
Mm-hmm.
Uh, uh,
Now, what's this server going to be?
so this server is going to just basically be the server. So instead of this, I'm going to have server dot server
Okay,
lesson basically, right?
okay.
And what is going to be the benefit of that is I don't have to pass all this
Ah, I see. Okay,
because all this will be part of the server configuration
got
data.
it.
I cannot remember. Is that the one? Is that the one? I don't think so. It's
This
not a
definitely
client.
sounds odd.
Let me just search for it. I have to
Yep.
search for it. Ah, don't remember which
Let's
is the
see how
one.
good goes
Oh, they have got good
documentation is.
documentation. They've got good
Okay,
documentation.
you just auto completed my sentence.
Assonance,
Hmm.
do they have? Are they creating a new one? No, they don't seem to. Server.
Import what? There is something called server HTTP. I just happened to see something. Server HTTP single
Mm,
word.
oh, I think yes, server. That is it.
Huh.
My bad. Yes, that should be it. And this should. I'm hoping this is correct. So address and handler should be a router,
Hmm.
right?
Yay.
And that works flawlessly, right?
Yes.
So, so I can specify a lot more configuration information here, basically.
Hmm.
That's the expectation,
Right. Makes sense.
right?
Put all
Uh,
that in one object here.
yes. So if you look at it, they've got address, they've got a handler, TLS config, timeouts, read
Hey,
timeout, write
nice.
timeout, idle timeout,
Nice.
maximum byte, maximum header bytes, right? So they've got a lot
Hmm.
of information that a lot of stuff that you can basically configure, right?
Nice.
And the default one was just allowing you to just tell you which is the port and hey, which is the router that you want to use and be done with it, right?
Right.
This allows you much more flexibility. Uh,
Yes.
one thing that we want to probably okay, one thing that as of now you're saying is I'm hard coding a few,
Hmm.
at least okay, I'm just using one parameter here and I'm hard
Hmm.
coding it,
Hmm.
right? So this is at 8080, right?
Correct.
And if you look at it from a production standpoint, if you have like a swarm of services, right?
Hmm. Hmm.
You can't have all of them listening to the same port. You want flexibility there, right? So you want to take this as a
Yes.
configurable parameter,
True.
right?
Hmm.
And for that, what I can do is I can create a, okay, I'll just let it remain here. I'll just create port, and there is a flag package that I can use,
Mm-hmm.
right? And it is pretty, and it will feel like using the argument parser that you probably may have used in Python. So what I'll do is this pass port. I'll give the name. This is this is the flag that you'll have to pass on command line.
Mm-hmm.
This is the default value
Mm-hmm.
if no value is given. And this will be code for listening request, right? Then I do flag dot parse, right? So
Yep.
this logic
Mm.
should now, if I just do main, will work, right?
Yeah.
As simple. But if I do, let me do this 9090, right?
Okay.
Now if I
Let's
do
hit
this,
8080. What just happened?
uh,
What just happened?
oh wait, my bad,
Did we not?
my bad. We forgot to use it.
We
Yeah.
parsed it but didn't update it. Yes. Port.
Oh, and this is gonna crib because
Mm.
it expects it in a certain way and it expects a string, so we'll use a string conversion package.
Ah, I see.
That should be it.
No strconf.
We'll wait, we'll see if it is gonna still complain. Yeah, I don't know why it's still complaining, but this should work.
Just the ID being confused, I guess.
Yep,
Okay.
right.
8080, nobody there. 1990, anybody home?
Yep.
Yay! When it works, it's so simple. Yeah,
It's so simple, right?
correct.
Cool. So with that way, you can pass more flags. So anyway, we had discussed this,
Hmm.
right?
Hmm.
So this is plugin 12. There's one more way of using it, which is, well, it's not that important to know, but the other way of using it is basically, so instead of doing it this is the other API that the flag package exposes. So here
Hmm.
it is going to pass an integer pointer basically.
Ah,
You can dereference it and store it here,
okay.
right? Just a matter of your taste,
And both
basically.
both are equally accepted.
Mm, Both should work in my opinion.
Okay. I mean,
Right?
stylistically, is one preferred over the other?
Both of them are given again, as I'm saying, it depends.
Hmm.
So if you are someone who prefers to work directly with, uh, who prefers not to work with pointers if
Hmm.
possible,
So
then
it's
yeah,
not
sure.
like
The first one
one way is
is better.
deprecated or something like that.
No. Both
Okay.
both of them are valid ways, from
Okay.
what I understand.
Okay.
And yeah, it is a matter of choice,
Okay.
right?
Awesome.
I just like uh, it this way also. I mean, it does not make that much of a difference,
Hmm.
right? Cool. Okay. Okay, let me think. What else can we talk about? So there is, okay. So if you would have noticed till now, we have not done. Okay, so if I go here, right, the web server is running,
Mm-hmm.
and I just send it a kill signal, right, via the terminal.
Right.
Ooh, right. So if I check, right, this should correspond to a sickle, if I understand correctly,
That's generally 9 or something, no?
right? Like-
9 or 11.
okay, this is a
9.
second, my bad.
Sig
So this is a second.
130 is Sig.
128 plus the signal number.
Ah, okay.
So yeah, so
Sig
this,
interrupt.
so,
Control
so it
C
will be
is 2.
second, right?
Perfect.
Cool. So this is not something you really want to be doing on a production service, right? You
Correct.
don't want to just kill it randomly. You
Yes.
want to give it, you want to notify it that you want the process to terminate
Hmm.
and let it gracefully terminate, right?
Yep.
Because I mean, we are not really doing anything here, but if this was an actual web service doing some activity, it
Hmm.
may have some. So there would probably be some
State to
in-flight request.
save. Yep.
There'll be some in-flight request. There'll be some state to save. It would probably be talking with a bunch of database servers, right, or a
Hmm.
bunch of data stores,
Right.
basically, and it would be trying to either read something from them or push something to them, right?
Hmm.
So you want to basically give it time to exit in a clean, graceful manner,
Yep.
right?
Yeah.
So
Yeah.
for that, what we have is basically we want to have signal handling capabilities also in this piece of code, right?
Hmm.
So what you will do is you have a package called signal.
Nice.
It's got method called notify, right?
Notify.
And
Okay.
what notify takes is a channel. So for now, let's just assume that there's a channel called done, and we have to just let it know which are the ones that we care about, right? And let me just for now say OS interrupt and OS kill.
Okay.
Let's see if there is an OS terminate. Is there? Nope. Okay. Let's just assume this is it.
Hmm.
And let's just declare we have make OS dot signal. Okay.
Mm-hmm.
So this is, I think, the first time I'm introducing the concept of a channel.
Right.
For now, you can just assume that channel here is just basically providing you a mechanism
Hmm.
of passing information between two Go routines,
Okay.
right? So I'll elaborate a bit more on what it is supposed to be. But
Mm-hmm.
let's just assume there is some magic way
Hmm.
where once this OS interrupt or OS signal or OS kill signal is provided is received
Hmm.
from the operating system,
Hmm.
application will basically let anyone who is listening on the channel know about it. Basically, anyone can be listening to the channel and be notified that okay, yeah, hey, we got a signal, so we need to do whatever cleanup that we want to do and terminate.
Right.
Right?
Right.
That's the expectation.
So the name of the channel is done.
Name of the channel is done,
Okay.
right? Or call it sig, right? That
Okay.
to receive the signal, right?
Hey, the other got him. Okay. Nice.
Yeah. So what I want to do here is I want to, so this is a channel specific. So what I'm doing here is, so basically think of channel as a buffer, right?
Mm-hmm. Mm-hmm.
And think of different threads, right?
Okay.
So, uh, so basically, one thread is going to be producer and the other is going to be a consumer, right?
Okay.
And your channel is the buffer in which the producer is going to keep pushing content.
Sure.
It's think of it like a pipe. I think an OS pipe is probably a good example
Right.
where, right, in the pipe there's going to be a producer which is going to keep pushing content to the pipe,
Hmm.
and then on the other side there's going to be a consumer which is going to keep reading from the pipe,
Yeah.
right?
Right. But
And a pipe,
can there be like multiple consumers?
sure, there can be multiple
And
consumers.
then will a single whatever is pushed on the channel will be replicated to all of them, or the first consumer pops it?
Only the from what I know, only the first consumer will get it,
Ah, okay. So it's very much like a pipe then, yeah. It's a pipe.
right?
Hmm.
Okay. And like a pipe, I have not defined any uh, buffer allocation. I have not basically allowed any sort of buffering to take place, right?
Hmm.
But
Hmm.
I can basically give a size and tell, okay, so till the time, uh, say, say till the time two signals are not provided, you
Hmm.
can keep two signals are provided and they are not processed. You can keep adding more signals, basically, right?
Hmm.
So I'm allowing to buffer those signals. right?
Okay.
But since I've not had them, so writing to it will be blocked as soon as any signal is written to it
Hmm.
and not consumed,
Right.
right?
Got it.
Right. And this is the syntax for basically reading from a channel. Okay.
Okay.
If on the other hand I was writing to a channel, so this is the syntax saying I'm trying to write OS dot interrupt. So this
Mm-hmm.
is the way
Mm-hmm.
I write to a channel,
Mm.
and this is the way I read from a channel.
Okay.
Okay. And since there is no buffer, right?
Mm.
Writing to it is blocking, and reading from a channel is also blocking if there is nothing more to read,
Got it. Yes.
right?
Mm.
So what this basically means is the control flow will stop here till the time some data is not written on this channel, right? Because initially it will be empty,
Right. Makes sense.
right? So this is a good way of synchronization. So any code after this means that we have received a signal.
Yes.
Cool.
Got it.
Okay. Okay. So we have received a signal, and you can you can quickly log that. Okay.
What's a percentage V?
What a percentage V stands for, I think, value. Whatever is the value will be dumped here.
Okay, let's see this output now.
Right? And so if I just let it be like this, it's not going to do anything, right? Because I've not really asked it to do anything.
Hmm.
So because I'm not asking it to do anything, so yeah, it's being smart and not doing anything,
Hmm.
right? So
Uh,
I'll have to send it a,
L minus 9. Yep.
yeah, I've just specified the name,
Okay.
right?
Hmm.
So since I was not asking it to do anything, yeah, it's just stuck here.
Correct. It was able to kind of swallow that signal. Yep. It consumed that signal. But I
Right?
was hoping it would do that logger.printf received signal, and at least that should have come up, right?
That is what I'm thinking. That should have happened. Or maybe I'm missing something.
Is that arrow mark in the right direction? Sig.
Yeah, it is.
Okay.
This is. Oh, wait. My bad. My bad. Yeah. So, this method, listen and serve, is a blocking call.
Ah.
And this does not unblock
Hmm.
till the time the
It's
basically
like
the
there
server
is
has
an
it.
implicit sig inside that.
Right.
Hmm. So what's
So
it that
what
you're
we
doing
need
now?
to do, yeah, I'm just going to explain that. So this is the first time that we are making use of a Go routine. So think of it as creating a separate thread,
Okay.
right? And all I'm just asking is to create a separate thread,
Mm-hmm.
and in that thread run this function,
Ah. Okay.
right? So
Hmm.
it is no longer going to block here,
Okay.
right?
Maybe we
Like
can see that in the output of PS.
uh, I'll actually explain as to why you'll not be able to see it there,
Okay. This gets interesting.
right? And yeah, cool. It was able to work now
Hey, how come it returned?
because I'm giving it a signal here, right? I'm giving it a
Right. So
second.
it consumed the signal.
It consumed the signal and it moved ahead, right?
Ah,
Because this
right,
was the
right.
blocking call,
Hmm.
but I moved it to a coroutine. So basically, this is a separate. Well, for now, let's call it a thread,
Hmm.
right?
Hmm.
So because
Go
it is a
thread.
separate,
It's not a
yeah,
OS thread.
yeah, the technical term is a go routine.
Go routine.
So,
Okay.
right? So since it went into a separate go routine, so
Hmm.
this go routine will be
Hmm.
blocked on listen and serve.
Hmm.
But the current go routine, so like even the main
Is the go
function
routine.
is being executed in a go routine, right?
Hmm.
Like how we think about threads.
Yep.
When we are till the time we are not creating a thread, we are just running in the main thread, right?
Yeah,
So
right.
till the time you're not creating a go routine, you're running in the main go routine.
So once the main go routine exited at 43,
Huh.
the application quit.
Then the application
Hmm.
quit, right?
Okay.
Okay, now let me just talk a bit about Go routines. So the interesting thing about Go routines is that Go routines are not exactly your OS threads. Okay,
Hmm.
so and a Go routine is also not a green thread. So just to help you understand, a green thread is when when you are maintaining threads in the user space and you're not making use of the underlying OS threads.
Okay.
Okay, so you can basically map uh, say n green threads to a single uh, well, assuming the OS has a capability of providing you a thread
Hmm.
to a single thread
Hmm.
or to a single process, basically,
Right.
whichever way. So it does not matter if the OS is capable of providing you multi-threaded environment or not, right?
Got it.
That is all being handled in the user space. That is a green thread.
Okay.
And we have the standard model where your operating system will normally provide you a multi-thread environment, so you're making
Hmm.
use of an OS thread, right?
Hmm. Hmm.
A Go routine is in the middle where it is not exactly making use of green threads and it is
Hmm.
not exactly making one-to-one mapping for OS thread. So
Okay.
it is doing something called an M2N scheduling,
Hmm.
if I understand, if I remember that is the correct term, where uh, M Go routines are being mapped on N OS threads,
Okay.
right? So there is no one-to-one mapping, but there is no N-to-one mapping also.
Got it.
It's there in the middle.
So it's sort of like it heuristically decides to spawn the ideal number of OS threads required
Mhm.
to handle any given number of coroutines.
Yeah,
Okay.
some logic along those lines is probably
Sure.
running in the background,
Sure.
and that's all being taken care transparently
Right.
by the standard library
By
or
the way,
the
have
standard
you
runtime
seen any
environment.
examples where people explicitly request an OS thread?
I have not actually.
Okay.
I have not.
Okay.
Okay, and one thing about Go routines is that Go routines are lightweight in nature
Hmm.
compared to an OS thread,
Absolutely. Yep.
right?
Yep.
And so one of the benefit and the beauty of a Go routine is I can spawn off thousands of Go routines
Hmm.
without having to worry about the overhead involved,
Hmm. Yep.
right?
Yep.
Mainly because I'm not creating a new thread, so it is lightweight in some sense.
Yes.
And it does not imply that I have to do a context switch,
Hmm.
right?
True.
Because context switches are also expensive,
Yeah.
right? So since a new Go routine may not necessarily require a context switch,
Hmm.
so again, you're probably saving some important time there also,
Yep.
which leads to better performance,
True.
right?
Got it.
Okay. And okay, so this is what we were doing. And since you have got this, and now what I'm going to write now is just a standard way of doing things. I do not entire understand the entirety of it, but I'll just
Mm-hmm.
try to explain what I understand.
Okay.
Okay, so what we do is we create a context.
Okay. Ah, so you can assign this. So it's like a pair or a tuple, and you assign that. So both context and cancel get assigned.
Yes,
Cool.
right. And this is this is to be interesting, right? I This is also the first time we are using defer,
Mm,
and I'll just explain in a minute what defer is.
mm,
Okay. And once we have this, what we want to do is server dot shutdown ctx.
So error is not nil. We print something. If
Okay,
error is nil,
we'll
we
just say
probably exited
exited
gracefully.
gracefully,
Hmm.
right? That's all we want.
Hey, log.print and exit, right?
Exit. Oh, we don't really have to say explicitly exit, right?
It'll print both otherwise.
Oh, my bad.
Yeah, yeah.
Return. My bad, my bad.
Okay, this makes
Okay,
sense.
so we are doing this.
And the
This
other
should make
exit is
sense.
implicit. After line
Yeah,
56, it's implicit.
yeah. Okay, so if we look at, so okay, let's start with this. So we have something called a context package,
Hmm.
which provides you. So context package, as the name suggests, is for every request response, right?
Hmm.
Uh, Go has so the guys at Google just came up with a package
Hmm.
where you can create a context
Okay.
and you can add certain pieces of information in it,
Mm-hmm.
and you can basically share it to other methods also, other
Okay.
APIs which are making use. So this allows you to basically create some sort of information
Hmm.
which can be used by whichever is the method which is processing information, right?
Okay.
So all we are doing here is, from what this looks like, I and I don't completely understand this, but from what I understand,
Let's look
so
at the param names. Those are generally helpful, right? So
right, so all
with
you're doing is
timeout
so
takes a
all you're doing is
parent context.
it takes a parent context, which is so the default context, or the say
Hmm.
whatever is the context right now is,
Hmm.
I'm going to give this context as background, right?
Hmm. Hmm.
Okay, and what does context background do? It creates a non-null empty context, right?
Hmm.
And it say has some, all the values are probably default values, right?
Okay.
So it's like a clean slate to start with,
Hmm.
right? And to that I add a 5-second uh, timeout,
Okay.
right? And this basically gives me a context
Hmm.
with the information, the timeout duration set in it, and a cancel function, and the cancel function releases resources associated with it, right?
Hmm.
And from what I've read, it basically creates a go routine. Again, this is from what I've read. I'm not entirely sure if this is the correct thing or not,
Okay.
but it creates a go routine, right? And once the timeout is hit, all the resources are associated with the context are basically released. Yes.
What if
That
the
is
timeout is not hit?
no, oh, sorry, my bad. So if the timeout is hit, then you're
Uh-huh.
supposed to call cancel,
Okay.
because if you don't can call cancel, then the associated resources are not released. That is how it is.
So, okay, come again. So when we say context dot with timeout, it does something and then
It
it
is supposed
wait.
to do something within a deadline,
Hmm.
basically within some time. If
Hmm.
it does not happen, what you're supposed to do is you're supposed to call cancel.
As in it calls cancel or we are supposed to call
We are
cancel?
supposed to explicitly call cancel.
Ah, okay. So we got it returns a function immediately called cancel.
Cancel.
And
And if you
if,
see this comment here, right, releases resources slow operation completes before timeout elapses, right? If timeout elapses, it is expected to release resources. If it, okay, my bad, I think maybe I'm wrong. So if the timeout is not hit, but the resources need to be released, then you need to call cancel.
hmm,
If the timeout is hit, then those resources are automatically released.
hmm,
Okay, I
hmm,
hope that makes sense now,
yeah. So they
right?
are calling defer cancel as is, whereas we put it in a
Yes.
separate thread.
No,
In line
okay.
number
So
47 to 14, we put it in a separate go routine.
mm, not exactly, yeah. And that is what I was trying to explain. So
Hmm,
what does defer do?
hmm,
Defer is basically, so the way things work in Go is,
hmm,
I'm going to, so starting at line number 18, this function starts, right?
hmm,
And we'll keep doing stuff, we'll keep doing stuff,
Hmm.
and then we'll exit at line 57, right?
Yes.
Or say somewhere in the middle, say like line 54, I'm returning, right?
Yes.
But so at any of these exit points, when any of these exit points of the function is hit, right? I will then go to the defer stack, basically. I am not sure as to how it works, but this is how it
Hmm.
probably works. So think of it that there is a stack where I have kept things that I intended to do in this function, but I've not done yet,
So it's
right?
like so on in C we generally do this on error go to exit or go to fail, and there is a label at the end of the function called fail
Hmm.
where we do a bunch of cleanup.
Where yes, right? So a good example would be, say, if I'm opening a file, right?
Hmm.
I know how to close the file somewhere,
Correct.
right? So instead of trying to think of all the places where I need to close the file, what
Hmm.
I'll do is just after opening the file, I'll write a defer
Hmm.
file.close.
Hmm.
And what that is going to do is whenever I'm exiting out of that function,
Hmm.
right, that file.close will be executed,
Okay.
right?
So we probably
So
must do all sorts of conditional checks in code that we put in defer, right? So if F, then only do F dot close.
depends. So you can have multiple defers. So you can stack. That is why I said there's a stack, right?
Hmm.
And I can stack all my defers.
Right.
So in reading the code,
Hmm.
right? So if you see defer one, defer two, defer three,
Hmm.
then the way they're executed will be three will be executed first, then two, then one,
Ah.
right? Because it's a stack,
Hmm.
right?
Okay.
And since we are only using one defer, what that means is whenever we are exiting, right? We're calling cancel then.
Okay.
Yeah, whenever we exiting this function,
Hmm.
right? That is one thing. And
So contrasting this with line number 39, 47, we called a sub Goroutine.
yes,
We registered it as a deferred Goroutine compared to line number 39 where we registered it as a normal Goroutine which begins to run immediately.
no. So I would not call it a go routine because all it is waiting is it is going to run in the same go routine only. The
Hmm.
only difference being it is going to wait for this method to finish.
Okay. So it's
Right?
not a different Goroutine, it's still the same
It's not a
Goroutine.
different go routine. It's part
Hmm.
of the same go routine. It's just
Okay.
going to wait for this method to for this function to finish,
But
and then
why,
it's going
but
to.
then why do this func and parenthesis and that whole thing? If you look at the context or timeout inline help,
Actually,
it was
actually,
saying just do defer cancel.
actually, I don't need to do all that stuff. I can just call it defer cancel also,
Yeah.
and
Probably
this will
what
also.
we just removed.
You can just have a bunch of activity happening inside it.
Yeah, so what we just removed is probably creating a separate Go routine.
No, no, no. It's
No?
not going to create a separate Go routine. All it is going to do is so think of it as okay. So think of defer as the moment control flow in the current Go
I
routine
mean, defer,
is.
I get it. The
Mhm,
bits of code that we just removed on line 47, right?
mhm,
Func and everything
mhm,
that we had wrapped cancel.
mhm.
Is this creating a Go routine?
No,
No,
the only way of creating a Go routine is by using the
is
Go
just using
keyword.
Go. Okay,
Go
got it,
keyword.
got
So
it.
Go keyword is going to use Go routine. What this is going to do is the moment control flow exits out of this function
Yeah.
is so I'll have a stack of
So does
defer.
defer accept multiple functions?
Yeah, it should,
Okay. So if we had
right? So
multiple statements, we would probably need to do func and put braces. But
I
since we
can have
have,
multiple defers. So I can have, so let me just put it this way. I mean, this is not sane code, but I can do this. This should be valid.
and you can do defer cancel without func 3 times.
Yes, I can. Yeah, I can do it. So what I'm doing here is if I'm creating a function, what I'm trying to do is I can probably trying to bunch like
1, 2, and 3.
do bunch of cleanup here,
Hmm,
whatever I want to do basically,
got
right?
it, got it.
That's the reason I
We
think I
have a
was thinking
function
along those
around
lines.
it. That's the only reason. No subroutine, nothing.
I mean, technically, this is also a function, right? Cancel is also a function.
Yes.
So
I mean, if we
anyway,
have
what is
multiple statements, we want to wrap them inside braces.
yes,
Since we have a single statement, we can just directly do defer
we
cancel.
can just directly use this, right?
Got it.
right?
I think
And
we.
right,
Hmm.
so defer is within the same routine. The only thing is we are waiting for the control flow to exit from the current function,
Yes.
and then the control flow will transfer to the defer stack,
All right.
right, where
Right.
it will just keep popping every entry on the stack,
Hmm.
and it will just enter into that. And once it exits from that, it will
Hmm.
again pick the next entry from the stack. Once it's done with all the entries from the stack, it is going to go to the original caller
Hmm.
of the function,
Hmm.
right? That is
Sure.
going to be a defer. And if you look at func is similar to how you have a thread, right?
Hmm.
The
Hmm.
moment you invoke this goroutine,
Hmm.
right, at line number 39,
Hmm.
right, the goroutine is invoked. The goroutine, so the current goroutine, that is the main goroutine, may continue proceeding ahead, or it may pause, and the second goroutine is something that may be invoked, which will be running, or the other one is just created and is waiting to run. So again, the normal concurrency stuff, right? We
Right.
don't, we have not provided any sort of synchronization between these two Go routines,
Hmm.
so they can run at their own will,
Yes.
right? And yeah, so I also want to do this where uh, is not equal to http dot logger dot splitter.
Hmm. 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 Hmm.
Hmm, and capital F, that is it. Sure. Cool. I think this should.
So hold on. What did we just do? So we
So
created
what I
a
did
Go
is,
routine.
so in the Go routine, what I'm doing is I'm starting the server, which is listen and serve means bind to the address that I've given, right?
Right.
And start serving any incoming requests,
Okay.
right? And it is supposed to be a blocking method. The
Hmm.
only way it should unblock is that the server can no longer run, right?
And when would that happen?
If you look at it, always returns after shutdown or close. So if the server is shut down or close, right? At
So
that
if
point of
the
time,
main Go routine executes 52, 53 line
ah,
numbers,
yes,
then this other Go routine at line number 39,
right.
uh,
At line number
yeah,
40,
it'll
it will return an
return
error.
error. Okay.
With the error will be error server closed, right?
Hmm.
And if error server close is not the case, then we want to report basically that there was some issue, right?
Okay.
So I'll just show you an example of that,
So right now it'll just exit without printing anything. If
right? So this is, so what is happening, and let me just,
How do we see the multiple Go routines now?
how do you see the multiple Go routines in what sense,
So PS shows me all the threads.
right? So this was scrubbing now, right? Because I already have this running on port 8080,
Huh,
this script that
correct.
there is a listen failure and address is already in use.
Cool.
So it it hit line 42,
Hmm, hmm,
right?
hmm.
Because if I had not, uh, and what
Yeah,
will
and I got
happen now,
what happened. Yep. Um,
right? And if I do, uh,
Another Go
and if
binary
I give
tries
it an
to,
interrupt,
yes,
it will exit gracefully.
right. So when another copy of this main binary, Go binary,
Mm-hmm,
called main, tries to
mm-hmm,
register a server on 8080,
mm-hmm.
uh, at port 8080, it will
Yes,
fail. So
it
line
will
number
fail
40 fails in the second instance
in
of
the
the main
second
binary.
coroutine. Yep.
So when it did logger.fatalf, it just exited from the Go routine then, right?
Yes,
Hmm.
because fatal will basically log whatever was there and then exit the
What if we had just done print? Even in that case, the Go routine ends, so it would have exited here, right?
it would have exited.
Okay,
Yes.
okay.
I mean, if you, no, wait. the go routine would have exited,
Hmm.
but the process would still be running
Because the main routine is running.
because let me think about it. Yeah, because the main routine is expecting a signal, right?
Hmm.
So this would be blocked at waiting for a signal,
Hmm.
right? So that is not what we want, and that is why we did this.
All right. How do we see a list of Go routines active?
That is not something I have checked out yet. So I am not sure if you can see a list of running Go routines.
I mean, does Go have some sort of command? OS would probably not be aware of it. OS just sees one or two
So that is
processes.
what I'm saying. I am not sure if
Go
Go
exposes that.
allows you
Okay.
Go exposes that information in real time. I mean, you can do profiling of the bind of the application, right?
Mm-hmm.
And you can get that information as to how it ran,
Mm-hmm.
but I'm not sure if it provides you real-time information. Okay, that now 10 Go routines
Something
are
like Go
running.
PS. I'm
Yes,
just, yeah.
yeah, I'm not sure if something like that exists,
Okay.
right?
Hmm.
Cool. And I think this is what I had to share.
Nice. It's what, an hour and a half, 100 minutes. Yep. Cool then. Uh, this was fantastic introduction for me to Go.
Mm, cool.
Thanks again. Let's sync up on chat.
Yeah, let's do that.
Thank you. Bye bye.
Bye.